Now we will start with the mesh analysis. Now what is mesh analysis? What is this mesh in this mesh analysis? The meaning of mesh is loop. Smallest possible loop in a circuit is mesh. Considering this circuit, here what is mesh? What is this loop? What is the smallest possible loop? This is the smallest possible loop. This is the smallest possible loop. This whole is itself a loop, but there are loops in that loop. That is, if I name it as A, B, C, D, E, F. Now A, B, C, D, E, F is a loop, but it is not the smallest possible loop. Now see, A, B, C, F is a smallest possible loop. Here F, C, D, E is also smallest possible loop. So there are two meshes in this circuit, or smallest possible loops in this circuit. Therefore mesh is a smallest possible loop. Now what we are going to do exactly in this mesh analysis? In mesh analysis, they ask us to find the loop currents or mesh currents. Especially how? Now here, first of all, when the circuit is given, we have to see that how many meshes are there, basic loops are there. Here in this circuit there are two basic loops, one, loop number 2, and then they ask us to find the loop currents, that is current flowing through loop 1 and current flowing through loop 2. The procedure to find the mesh currents is called as mesh analysis. Now before proceeding in this section, I just would like to make you familiar with certain terms that you know already as per earlier sessions. This is 20-volt battery. Now X, Y, X, Y. If I want to move from X to Y, then is there any potential drop or potential gain? See, I am moving from higher potential to lower potential, then there is a potential drop of 20 volts. And here I am moving from negative. If I want to move from X to Y, I am moving from negative potential to higher potential. That is, there is a gain of 20 volts. Hence, you have to remember this small point while solving it. We will be seeing it. Now we will start with the mesh analysis of the circuit. We will consider a sum and then we will understand what is mesh analysis. Considering this sum, in this circuit, they have given the circuit and they have asked to find the loop currents. Now, I will just make you note down certain steps of mesh analysis. Step 1. Assume currents I1 and I2 in loop. Assumes currents I1 and I2 in each loop. What I will do is, over here, I will assume how many loops are there. Here, number of loops is equal to 2. Hence, I will assume two currents I1 and I2. That is, I will redraw the circuit and I will assume I1 and I2 in the circuit. Now, step 2, I will write KVL in each loop. That is, step 2, write KVL in each loop. Now, while writing KVL, there are certain things we have to know or we have to remember. What are they? While writing KVL, we know that current going from here is I1 and current going from here is I2. But you have to always remember, while writing KVL for loop 1, always assume that I1 is greater than I2. That is, write a sub point while writing KVL in loop 1, assume I1 greater than I2. While writing KVL in loop 2, assume I2 is greater than I1. You have to assume these two things. Always assume that I2 is greater than I1. Now, while writing KVL in loop 1, I will just start. I will start writing KVL in loop 1. For loop 1, I will start from here. I will move from here and then again come at this point, considering any point. Going from negative to positive, there is a potential gain, rising potential, therefore plus 20. Again, from here, what does resistor do? It consumes the power. Therefore, while moving from 10 ohm resistor, there is always a potential drop, and resistor always consumes the power. Therefore, there is a potential drop. I will write it in minus 10. What is the current through that? I1. And again, while moving from 5 ohm, what I will assume it? While writing KVL in loop 1, assume I1 is greater than I2. So, the current flowing from here will be I1 minus I2. Minus 5. I1 minus I2 is equal to 0. This is our first equation. Then, now, next, we will be writing KVL for loop 2. While writing KVL for loop 2, we will assume that I2 is greater than I1. Now, while moving from here, now we are knowing that while moving from a resistor, I will just consider this point and I will again come to this point. While going from 10 ohm resistor, I2 is going from 10 ohm resistor, but while going from any resistor, what happens? There is a potential drop. Therefore, writing it as minus 10 I2, and then I have come here. Now I am going from positive potential to negative potential. What it is happening? That there is a potential drop because we are going from higher potential to lower potential. Therefore, I will write it in minus 10 volts. Again, I am coming from here to here. Now, what I have told, that while writing KVL in loop 2, assume I2 is greater than I1. That is, now difference of current will be flowing from here. What is the difference? Minus 5 I2 minus I1 is equal to 0. Are you getting it? While moving in loop 2, we assumed that I2 is greater than I1. While moving in loop 1, we assume that I1 is greater than I2. Always. This is equation 2. What is step 3? Solving these equations to get step 3 is solve this for I1 and I2. That's it. You have to solve these equations to get I1 and I2. Now simplifying these equations, what we are getting? 20 minus 15 I1 plus 5 I2 is equal to 0. That is, if that equation goes 15 I1 minus 5 I2 is equal to 20. This is my first equation. Now I will be solving for second equation. I'll just rub these steps. Now over here, if my 10 goes on that side, I2 minus 5I2 plus 15I1 is equal to 0, and here there is, sorry, there is 5. Now 5I1 minus 15I2 this 2. This is my equation 1 and this is my equation 2. Solving these two equations, we will see what we will get. So these are the two equations, simplified equations. Now solving for these two equations. 15 minus 5 20 5 minus 15 10. I1 I have got is I1 is equal to 1.25 amperes. I2 is equal to minus 0.25 amperes. Now they have said that I2 what I have got is negative. I2 is negative. That is, here my assumed direction of I1 is towards right. Along with magnitude, you always have to specify the direction. And this here over here also we have assumed that the current is clockwise. Hence, our current value magnitude is 0.25 and sign is negative. That means that the current is actually going anti-clockwise. It is not going clockwise. That is, we can also write it as 0.25 amperes clockwise. This is our final answer for the question. So this is basically a mesh analysis. We will see more problems, more tougher problems in this technique. And now consider this sum. They have asked over here that we have to find the current flowing through 6 ohm resistor by mesh analysis. Now here 6 ohm resistor is over here. Resistor is over here. So we will assume first, what is the first step in mesh analysis? Always assume loop currents or mesh currents. I will assume current I1 is flowing in this loop, I2 is flowing in this loop, I3 is flowing in this loop. Now applying KVL in each loop and we will get the equation related to I1, simultaneous equation related to I1, I2 and I3, and we will solve it by using calculator to get I1, I2 and I3. And then we will make I1 equal to I through 6 ohm resistor, as I1 is going through 6 ohm resistor. The value of I1 is our answer. Now first of all, applying KVL in loop 1. This is actually 2 volts. So starting from this point, and I will again come here to here. Now see, there is 2 volts. As we are going from positive potential to negative potential, what is there? There is a potential drop. Therefore, I will write it this in negative. Then I am moving through a resistor. Always going through a resistor, there is a consumption of power. Therefore, there is a voltage drop. Therefore, I will write it as minus 6 I1. After that, coming over here, I am going from negative to positive potential. What it is happening? There is a gain in potential because we are going from negative to positive. We are moving in this way. So I will write there is a gain in potential, therefore plus 19. After that, we are going through a resistor, but always going through a resistor, there is a drop in potential. Therefore, going from 1 ohm resistor, there is a drop in resistor. But what is the current? -1 and current through 1 ohm resistor. See, while applying KVL in loop 1, which is the greatest? I1 is the greatest, and rest all the currents are small. Therefore, here a difference between the two currents will be flowing, and it will be denoted by I1 minus I2, as I1 is greater while applying KVL in first loop. Is equal to, again coming at this point, 0. Now what is this? -20, -2 plus 19, that is plus 17, -6, -1, -7 I1, then minus plus I2 is equal to 0, and rearranging the equation, I1 minus I2 is equal to 17. This is my first equation. Alright, now we'll see the second one. In second one, I will just consider this point. Now, moving along this point in clockwise direction. Now, while going through a resistor of 2 ohms, there is a drop in potential, therefore -2 into current through 2 ohm, that is I2. After that, coming from here, difference between I1 and I2, but now I2 minus I1, as I2 is greater than arrest all while applying KVL in loop 2. After this, we are going from here. Difference between I2 and I3 is flowing through 3 ohm, but now I2 is greatest of all. Therefore, I2 minus I3 is flowing through this loop. Therefore, and there is a drop in potential. Therefore, -3 into I2 minus I3, and then coming over here, you are going from negative lower potential to higher potential. That is a gain. Therefore, I will write it in plus 25 is equal to 0. Now just rearranging, -2, -1, -3, -6 I2 plus I1 plus 3 I3 is equal to -25. This is my second equation. Now after that, writing KVL in loop 3. While writing KVL in loop 3, what is we are going from here? I will just consider this point, moving clockwise. I am going to resistor of 3 ohm. Now the difference of I1 and I3 and I2 is flowing, but now I am applying KVL in loop 3. Therefore, I3 is the greatest of all. So here difference will be I3 minus I2, and there is a drop, 3 into I3 minus I2, and I am going from positive to negative again. Then what? There is a drop in potential, and then again through 1 ohm only I3 is going, -1 I3 is equal to 0. So just simplifying this equation, -3 minus 4 I3 plus 3 I2 is my equation number 3. Can I just rewrite these equations in a much simpler form? That is, I'll just make this 7 I1 minus I2 plus 0 I3 is equal to 17. This is my one instead of this. Can I just rewrite this equation that I1 minus 6 I2, I1 minus 6 I2, and then can I just interchange this, that is 0 I1 plus 3 I2 minus 4 I3 is equal to 3. These are our three equations, three simultaneous equations. Now we'll solve by calculator and we will just get the value of I1, I2 and I3. And what are these values? You will see just sing. Seven. I1 is, the value of I1 is 2.9504 amperes. Value of I2 is 3.65 amperes, 6534 amperes. Value of I3 is -2. So these are the values of I1, I2 and I3. Now again in this sum, consider this sum. Here they have asked to find the value of Vx using mesh analysis. To find the value of Vx, we should know the current flowing through this 40 ohm resistor, because this Vx is across 40 ohm resistor. What is Vx? I 40 ohm into 40. So to know Vx, we should know the current. Flowing through 40 ohm resistor. Hence, again we have to find this loop current. So just as they have already given the mesh analysis, we should understand that we have to find all the loop currents. So starting with our first step, that is assuming loop currents. We will assume currents. I'll assume that I1, I2 and I3. Three currents are flowing in this three basic loops, where I3 is I through 40 ohm resistor. Now we will find first I1, I2 and I3 and then make I1, I3 is equal to 40 ohm, and then we are getting the value of Vx. Now writing first equation for loop 1, 80 minus, because plus 80, because we are going from negative to positive, that is there is a gain, rise in potential, therefore 80, and then while moving through any resistor there is a drop in potential, therefore this minus 10 into I1, moving through here it will be minus 20 into I1 minus I2, again moving from here it will be minus 30 into I1 minus I3, and then again coming here is equal to 0. Rearranging these terms, minus 10 minus 20, minus 30 I1 plus 20 I2, not minus 30, it is minus 60, minus 60 I1 plus 20 I2 plus 30 I3 is equal to minus 80. This is our first equation. Now applying KVL in the loop 2, moving from here, I will take this point. We are going from negative potential to positive potential, therefore there is a gain in potential plus 30. As we are going from negative potential to positive potential, therefore it is plus, and then after that going through resistor, there is a drop in potential and I2 is the highest, therefore minus 5 into current through 5 is I2 minus I3. Again going through this resistor, there is a drop in potential, therefore there is minus 20 into I2 minus I1 is equal to 0. Then solving this, rearranging it, I will get plus 20 I1 minus 25 I2 plus 5 I3 minus 30. This is my second equation. Again writing KVL in third loop. Coming from, I will just consider this point, rotate and I will again come over here. It is minus 30 into I3 minus I1 as I3 is greatest, minus 5 into I3 minus I2 minus I3 into 40 is equal to 0. Right? Now just simplifying it, what will be my I1 plus 30 I1 plus 5 I2 and then minus 35 I3, no 35 plus 40, that is actually 75 I3 is equal to 0. This is my third equation. Now I will just substitute these values in my calculator and then find the values of I1, I2 and I3. I'll just I1, I2, I3. I'll just substitute it in my calculator. Minus 60, 20, 30, minus 80, 20, minus 25, 5, minus 30, 30, 5, minus 75. The value of I1 is 3.76 amperes. 3.76 amperes. Value of I2 is 4.57 amperes. 1.80 amperes. These are the three values of I1, I2 and I3. But what is our Vx? Vx is equal to 40 into current through 40 ohm. But what is this I40? It is I3. What is I3? 40 into 1.8. Value is Vx is equal to 40 into 1.8. That is 7.72 volts. This is our final answer. In this way, we have to solve the problems of mesh analysis. It's very simple. Just you have to assume 3 currents or any number of, the number of currents will be equal to number of loops. In university exams, actually, basically 2 to 3 loop problems only come. Max to max 4 loop problems are coming. But then too, they are very simple.